let us keep going and I'll talk about example number 4 in this video. So that was example 3 just now, the one that had a slant asymptote. That was super fun. To find the slant asymptote, we had to do the long division. So that's a good review. And I did everything by hand, you guys. I did not use a graphing calculator. I only used Desmos graphing calculator to check my answer, right? We checked it, but we could do everything by hand. All right, so let's take a look at example number 4, what kind of fun function we have this time. Example 4, it says graphing a rational function with more than one vertical asymptote. Oh dear, this is going to be a little more challenging. So they said graph the rational function f of x equals -16 over, and you see the denominator is a trinomial. It's a factorable trinomial, I hope. So let's get right into it. Let's find the vertical asymptote first. We set the denominator equal to 0. Okay, well that is x squared minus 2x minus 8 equals 0. And let me factor this, okay? Two numbers that multiplies to be 8. 4 times 2 is 8. Make the 4 a negative, 2 a positive. They will add up to -2. So we're done factoring. So if I solve these, I get the vertical asymptote is at x equals 4 and x equals -2. Oh my goodness, we have two vertical asymptotes, but that is okay. So plot x equals 4 with the dotted line. Dot, 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 dot. 1 second. And another one at -2 with the dotted line. Another dot, 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 dot. So guess what? Now we're going to have to find graphs in 3 intervals. Okay? Okay, what I mean by 3 interval is this. Watch carefully. The one to the left, like one to the left of that red line, right? And we need one in the middle, this pink one. And we also need, lastly, just the one on the right side of the red line. So we need 3 graphs here, okay? Oh, goodness. Okay, but we got this. Now what? We found the vertical asymptote. How about we try to find the horizontal asymptote, if it has any? Horizontal asymptote. And in order for us to do that, I always just talk about the degrees of the numerator and the denominator. Let me zoom in and talk about this. Now, -16 is just a constant. So, if you want to put x in there, that is x to the 0th power, isn't it? So, the degree of the numerator is 0. Degree of the denominator is 2. So this is the case where n is smaller than m. And we organize all the cases during class today. If this happens, guess what? There is no, whoopsie, oh my gosh, I'm sorry, I almost messed up. This means the bottom of the fraction, the denominator will dominate the quotient. We're going to have a horizontal asymptote at y equals 0. Whew, I almost made a mistake. The bottom is bigger than the horizontal asymptote is at y equals 0. I said bottom is bigger, but if the degree of the denominator is bigger than the degree of the numerator, then we have a horizontal asymptote at y equals 0. Ooh, I almost made a mistake. So let's go ahead and draw a dotted line at y equals 0. And guys, remember, let me go scroll up all the way up to the first couple examples that we went over in class. Look at this one for me. Example 2, during class, we were given a function, right? We were given a graph and we were reading parts of it, right? I have a feeling it's going to look something like this. We'll have some graph to the left, graph in the middle, and graph on the right side of the rightmost vertical asymptote. So our job is to plot some points now. There is no slant asymptote because we have a horizontal asymptote. Okay, slant asymptote only exists when n is bigger than m by exactly 1. And that's not what's going on here, right? So let's see, how do they want you to graph? And I got this problem from Alex. It says, then plot 2 points on each piece of the graph. Oh my gosh, I hate this. Why? Because that means I need 2 points on each of these 3 areas. So I'm gonna need to plug in 6 different points. That's okay. That's okay. So first, I'll do my XY table. And to the left of -2, maybe I can do -4 and -6. I'll just space it out, okay? I'll plug in -4 and -6 into the function. So if I plug in, by the way, the function is -16 over x squared minus 2x minus 8. I'll set it up, but I will use my scientific calculator to evaluate the value, okay? To find the value. -16 over -4 squared minus 2 times -4 minus 8. I have a feeling this is going to be a bad number. Well, we'll see about that. So I'm typing this into my scientific calculator. If you do not have a scientific calculator, I suggest you use Desmos Scientific Calculator. Google it, guys. It's going to save us some time because we do not want to do this arithmetic by hand. If I plug this in, oh my goodness, what a beautiful number. I got -1. So that means I will plot a point at -4, -1. Next, if I plug in -6 in here, everything will be exactly the same, but I'm just going to change that number to -6. And I am typing this in my scientific calculator, which you cannot see because it's on my hand. It's in my hand. Ew, it's not that nice. It's -2 over 5. But hey, I can get an exact decimal of it. So instead of this, I will plot -6. And if I do -2 divided by 5, that is -0.4. Don't convert it into decimal in Alex's homework. Alex will graph the exact fraction values for you. Okay? I'm just doing it because I have to do this by hand. So let me plot those two. So I have -4, -1. 4 to the left, down 1. So here's my first point. And the next point is -6, -0.4. -6, -0.4. So pitiful, but it's gonna be just like right here. But look at what I'm about to do, okay? I'm gonna sketch the graph in that bounded region. The graph will go to the left, but as the left end behavior is just following that horizontal asymptote, it's gonna get really, really close to that blue horizontal asymptote. It's not going to cross it. So it looks like mine's almost crossing it, so I'll try to do this better. It's getting really close to it, but it's never touching it. And to the right side, it's gonna come down, but it's gonna just get really close to that red vertical asymptote, but it's not gonna cross it. So we figured out the side right there. Now let me go to the middle section and figure out what it looks like. The middle, I can use numbers like -1, 0, 1, and 2, and 3. Really, guys, honestly, the more points you plot, the more accurate your graph will be. But I'm just gonna get -1 and maybe 3 in here. -1 and 3. Go ahead, go to the party. -1 and 3 in there. Just my just my random choices. Hold on. Let me go in and add a page because I feel like I'm gonna need another page after this. Add a page. Okay. If I plug in -1, I will get -16 over -1 squared minus 2 times -1 minus 8. I'm praying, I'm thinking, please be a nice number, please be a nice number. If not, you guys should be okay on homework because they graph literally anything. I just need something that looks like an exact decimal. I got 16 over 5. It's not the nicest number, but I may be able to convert this into an exact decimal just to get an idea of where it looks like. It's 3.2. I think I can go with that. So I'll plot that, and I'll plot this time plug in 3. But I honestly, I believe your homework will tell you to just plot 1 point in each interval. Oh, I did something wrong. I need to plug in 3 in here. Such a tedious process, don't you think? But somewhat soothing, I think. It's not bad, it's just a lot of work. Alright, I plug that in, and I got 16 what? I got 16 over 5 again. Guys, I don't believe it. I don't believe this is right. So something must be wrong because, hey, maybe it's not wrong. Not necessarily. Who knows? Maybe it's coming back up. Okay, I thought this was wrong. But hey, I'll plot it and see what the maybe the graph is curving up. You see? I'll check that. So I have 2 points, -1, 3.2, and 3, 3.2. -1, 3.2, and 3, 3.2. I think it's going to do a little U shape, guys. I think it's going to look like, hold on. We'll do something like this. How will I know with just pre-calculus skills? I wouldn't know because I wouldn't know about the relative minimum or concavity or any kind of crap like that until we actually go into calculus. So this is my best guess. And if I want to be a little more sure, I will plug in x equals 1. And real quick, I will do that on my calculator, but I'm not going to write down the work. If I go ahead and plug in x equals 1 into this function, guys, hold on. If I plug in 1, it gives me 16 over 9. And 16 divided by 9 is 1.7 repeating. So it's not a nice number, but it's definitely down here somewhere. 1.7, it's close to 2. So yes, I think it's going to look like a nice U shape in the middle. But we can check this by using our graphing calculator when we are done. But because I got two y values both at 3.2, I had a feeling this is going to curve up instead of going down. So that's my best guess for the middle section. Let me go and figure out the 2 points on the right side. I will plug in 6 and 8. Why not? 6 and 8. No, maybe I'll plug in 5 and 6. Just two random numbers to the right side of the red line. I'll plug in 5 and 6. What happens if I plug in 5? And what happens if I plug in 6? All right, let me set it up. Guys, we can do this super fast, but that will be confusing. So I want to do this slowly. So if I plug in 5 into this function, what will that give us? I got -16 over 7. Unfortunately, I think that's a decimal. It's not a good point. So if I'm doing this completely by hand without any Alex or any calculator, I will throw this one out because this is approximately -2.286. I guess I don't have to throw it out. I can still plot this. I'll just make my dot super fat so it's around that point. I'll do that instead. So let me go ahead and plug in 6 this time. 6 squared minus 2 times 6 minus 8. I hope this gives me a little better number. But you see the process, right? It's just once you get your asymptotes, you just plug. Oh my gosh, look at that beautiful number. Guys, I got -1. I'm tempted to do one more. Can I please do one more? I'll do 8. If I plug in 8 into this function, I have a feeling that maybe the even numbers will give me nice answers in this particular function. If I plug in 8, guys, I got syntax error. Oh, because I did the wrong thing. Okay. I got -2 over 5. which is nice, a little bit better. 8 and negative 2 over 5. I'll plot that instead because negative 2 over 5 is exactly, I can divide and get negative 0.4. That's better than approximate. So do not ever graph these or plot points approximate decimals in Alex because they're going to mark it wrong, okay? So let's plot 6, negative 1. Let me do that first. 6, negative 1. Okay, I got that plotted. And next one is 8, negative 0.4. 8, negative 0.4. So I'll just put my dot really fat in between 0 and negative 1. And I have a feeling, I know what it looks like. So to the right, it's going to follow that horizontal asymptote, that blue line. But to the left, it's going to keep on going down and go down along that vertical asymptote. So that is it. That is the best I can graph this rational function. So this is what we're going to do now. Oh wow, I've been doing this for the last 16 minutes. I'm going to now graph this using Desmos sign graphing calculator to see if we got this right, okay? So I'm gonna go ahead and graph y equals, I'll start all over again, negative 16 divided by x squared minus 2x minus 8. Oh, I'm already happy. This looks just like what we had by hand, don't you think? We had that little U shape in the middle and the graph going down and it looks like, isn't it beautiful? But just to be sure, how about we graph some of these asymptotes that we had? We had the first vertical asymptote at x equals 4. Ta-da, that's good. We had the second asymptote at x equals negative 2. And ta-da, that looks good too. We had a horizontal asymptote at y equals 0. And I can see that the graph is following this green horizontal asymptote to the left end and to the right end. So we got this right. So use the graphing calculator to check your answers, please. But the goal of this lesson is that you know how to graph these rational functions without the help of a graphing calculator. So we did that. Just wanted to check the answer with the graphing calculator, right? But it does require a lot of work. Okay, so that's it for this video. I will come back for the very last example. Actually, I think I got 2 more. This is kind of fun now. All right, I'll be back with example 5 very soon.